Sound. Sound is a form of energy which produces a sensation of hearing in our ears. Production of sound. How sound is produced? Sound is produced due to the vibration of object. Suppose when we strike this object, it starts vibrating, and due to this vibration, sound is produced. Okay, can you hear vibration? Okay, so sound is produced due to the vibration of object. And what do you mean by vibration? Vibration is a periodic back and forth motion of particles of an elastic body or medium about a central or mean position. It is also named as oscillation. Have a look. When we strike any object or hit any object, it start moving. This is the mean position of this object. Okay. When we hit this object, it starts moving back and forth. Back and forth. Okay. This motion produces sound, vibration, which produces sound. So, what is vibration? Vibration is a back and forth motion of any object from its mean position, from its central position. It is also named as oscillation. For example, when we stretch strings of guitar, it vibrates to produce sounds. You all have seen guitar. It has strings. Okay, when we stretch strings, it vibrate and sound is produced. When membrane of table is struck, it vibrate to produce sound. Okay, membrane of drum, when membrane of drum is struck or strike, it vibrates and produce sound. So sound is produced due to the vibration of object. Got it? Now, propagation of sound. The traveling of sound is called propagation of sound. Traveling of sound is called propagation of sound. Sound is propagated by to and fro motion of the particles of the medium. Means sound is produced by vibration, or we can say by the to and fro motion of the particles of the medium. We know that sound needs a medium to propagate, whether it is solid, liquid or gas. Okay. Sound does not travel in vacuum. It needs a medium to propagate, whether it is solid, liquid or gases. Okay. When an object vibrates, the particles around the medium vibrate. Okay. The particle in contact with the vibrating object is first displaced from its position. So each particle disturbs the other particles. Suppose when we struck this object, then what happens? When an object vibrates, particles around the medium, this medium, solid medium, it also vibrates. All the particles start vibrating. Okay, the particles in contact with the vibrating object is first displaced from its position, and each particle disturbs the other particles. Okay, in contact. Thus, the disturbance is carried from the source to the listener, from the source to the listener, our ears. Okay. So when we struck any object, suppose when we struck this object, okay, then what happened? This particles in contact with other object is first displaced, and then this particles will also vibrate, and it disturbs the other particles, neighbor particles. In this way, disturbance is carried from the source to the listeners. Okay. Now medium, the matter or substance through which sound is transmitted. The matter, solid, liquid or gas, through which sound is transmitted is called a medium. A medium is necessary for the propagation of sound waves. Without medium, sound cannot produce. Okay. So, in vacuum, sound does not produce. Medium is necessary for the propagation of sound waves. The sound cannot travel through vacuum. It needs a medium, can be solid, liquid or gas. Sound cannot travel in vacuum. Now, wave. What is wave? Wave is a phenomena or disturbance in which energy is transferred from one point to another without any direct contact. So wave is a phenomena or disturbance in which energy is transferred. Suppose when we strike this object, energy is transferred from this medium, from this solid, from one object to another object, to the air, from solid to air, then it comes to our ear. Okay, so from one point to another without any direct contact between them. Okay, so wave is phenomena or disturbance in which energy is transformed from one point to another without any direct contact. We don't need to direct contact to listen sound. Okay, between them, because we know sound can travel through air. So for example, light and sound is considered as a wave. Sound is also a wave because it does not need any medium, does not need any direct contact. It needs medium, but it does not need any direct contact. Okay, between source and listener. Okay. Now types of wave. On the basis of direction of propagation, means movement of sound, wave are categorized in two parts: longitudinal waves, transverse wave. Now longitudinal waves. These are the waves in which particles of the medium vibrate along the direction of propagation of the wave. For example, sound wave. When we strike any object, the particles of the medium vibrate along the direction of propagation of wave. For example, sound wave. And transverse wave, in this type of wave, particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave. For example, waves produced in a stretched strings. Okay. And another type of waves which do not require any medium for propagation are called electromagnetic waves. Does not require any medium. These waves can travel through vacuum also. For example, light waves, X-rays, etc. Now, compression and rarefaction. Compression is the part of wave in which particles of the medium are closer to one another, forming the region of high pressure and density. Okay, compression are represented by the upper portion of the curve called crest. So in this diagram you can see compression are represented by the upper portion of the curve called crest. Okay, and refraction is a part of wave where particles is spread out to form a region of low pressure. Compression is a part of wave in which particles of medium are closer to one another, forming the region of high pressure, whereas refraction is a part of wave where particles is spread out to form a region of low pressure. And it is represented here also, you can see it is represented by the lower portion of the curve called trough. Okay, compression is represented by the upper part of the curve called crest, and the rarefaction represented to form a region represented by the lower portion of a curve called trough. Okay, here you can see lower portion, upper portion. Got it?